Hi everyone, my name is Lokesh Kumar Lal, and today I'll be presenting on UX and the ethical framework for my predictive congestion detection system. And this is the final presentation in this specialization. So thank you all. So to double click my task analysis, shows that the network engineers currently suffer from a cognitive overload, having to manually correlate telemetry from thousands of routers. And by leveraging ML and AI, we simplify this task, So essentially, we move the engineers from a role of data detectives to decision validators. So this insight kind of allows us to design a UI that focuses on verification rather than, raw data searching. Now, the user here interacts with a proactive dashboard. Key to our AI UX is transparency. So we don't just show an alert, we provide an explanatory tab, that kind of highlights the specific drivers like a BGP spike or a regional holiday, behind a prediction. And we also communicate uncertainty clearly, an 85% confidence score, for example, tells to an engineer to act, while a 50% score, suggests that they should investigate. And finally, we kind of include a feedback loop, where the engineers can use to mark alerts as accurate or false positive, which essentially, retains our model to improve precision. So that's about the UX experience. Now, in terms of the privacy consideration, because we operate on the backbone of the internet, privacy is non-negotiable. So it's, a center for our GDPR and CCPA compliance. So we kind of meet our legal obligations through data minimization, collecting only the relevant interface-centric metadata rather than punting a bunch of packet payloads. And we also use IP hashing to anonymize the flow data, or ensuring that while we see the traffic patterns, we can never identify or track the individual user behavior in a nutshell. Now, to meet the goals of ethical AI, where there are a few considerations. So first is fairness, where we kind of mitigate the selection bias by ensuring our training data comes from diverse global regions, not just high bandwidth Western hubs. Then we have accountability, where we maintain a human in the loop. So the AI acts as a co-pilot, but it cannot read out traffic without an engineer's authorization. And lastly, we maintain transparency. So every model prediction is logged in with the version number, like a time, like a software stamp, and input factors for the feature audit can also be calibrated accordingly. Now, here is a quick demo of the final system interface. So what we see here on the left-hand side is that the ML engine identifies the specific routing interfaces at risk, and you can see the NYC edge, which is the example here, has interface with 94% confidence score for congestion in the next 38 minutes, which is about to happen. And on the right-hand side, we see the traffic forecast graph as well, that clearly shows the projected spike crossing the red capacity threshold. So this lead time gives the engineer that cushion or that power to click readout before a single packet is dropped, and kind of mitigates a problem. And then, it surfaces as a proactive measure rather than a reactive one. Now, to conclude, this project demonstrates how we can transform the backbone of our internet from a reactive environment to a proactive one, like I mentioned in the previous slide. And by focusing on task analysis, user experience, we have kind of moved the burden of data correlation away from the engineers, allowing them, time to focus on high-level decision making or other important stuff. And the most critical piece is, by adhering to the privacy laws, we ensure that AI is ethical, it is transparent, and we build the necessary trust that is needed to keep the global infrastructure. So that's been my time. Thank you, everyone, for your time throughout this specialization. Thanks.